So what we should be seeing here is an example of our log-log graph paper. And so in this case, I have this set up so that when you get data, you'll be getting optical density data, and you'll graph it on the vertical axis. You'll be getting cells per mil data, and you'll graph that on the horizontal axis. Notice what I've done is I've made up, the range of my numbers, but I got 1 up 10 to the 4th cells per mil, 10 to the 5th, 10 to the 6th as you move across the 10 to the 4, 10 to the 5th, 10 to the 6th, as you move across the x-axis. And then I have the optical densities. Notice that you're doing this on the log scale. This first one, that's a 1. I put down here 0.01, and then the next log scale is right here. And so what you do is you move this decimal point over one place. So this was 0.01, this one's 0.1. That means the next one is going to be 1.0. So that's how you're going to graph how you're going to get the axes set up on both of these kind of graphs you're going to do for the growth curve. So now let's pretend these data are the data we got. Notice they're not a straight line. It is showing a trend of as the optical density increases, so too do the cells per mil. And what you'll do is graph those, and you come back and you make a best fit straight line with these, okay? You'll use a piece of paper or a ruler, which would be really nice. And now look at what you've got on this particular information here. You got a log graph paper. It's optical density versus cells per mil is the actual graph. And this is like a standard curve. Because look at what this allows you to do. This allows you to say, all right, at a certain absorbance in my little flask, I want to know how many cells are in there. I don't want to have to go out and graph this all over again or make a bunch of cells per mil plates. What a pain in the rear. With this standard curve, I don't have to do that. I can take my flask, stick it in the spectrophotometer, and get a reading. Let's say I get a reading of 0.06, which is right here. What does that correspond to in cells per mil? You just come across here to your red line, your best fit line. You come down here, and you go, okay, this is 1, 2 times 10 to the 4th, 3, 4, 5, 6, 7, 8, 9, 10 to the 5th. So this one is 0.06 is the equivalent of approximately 7 times 10 to the 4th cells per mil. So that's the utility of this kind of graph, and that's why you're going to try to graph this. This will be the hairiest data you get, by the way. This is very difficult because cells per mil data is not always clean. Absorbance data, OD data is pretty good, but the other isn't, okay? So that's how you're going to do the log paper, how you're going to use that in your calculations. Now, the semi-log paper is a lot easier. The semi-log paper is just simply going to be graphing optical density in the vertical axis. And again, we'll make this up. We'll say this is, in this case, we'll go again, 0.01, 0.1, 1.0. So those are your ODs you're reading right out of the spec. Horizontal axis is time. You're going to do 2-hour time points, every half hour in your case. So 0, 30, 60, 90, 120 minutes. And at time 0, I get an absorbance of 0.04. At time 30, I get an absorbance of 0.09. At time 60, I get an absorbance of 0.09. At time 90, I get an absorbance of 0.2. At 120, I get an absorbance of 0.55. Just say, okay? Same thing. You will draw a best fit line, not a connect the dots line. And from this, you can do, like we've talked about in class before, figure out generation time. You, again, literally go from point 1, come across here, come down here, and there's my, where it's crossing the timeline. Point 1, so twice that absorbance or optical density is, lo and behold, point 2, which would be right here. So you come across point 2, you come down here, and that distance, or that difference, is your generation time. So you'll be calculating the generation time of your organism, and you'll also be trying to make a standard curve, and that's what you'll turn in. I hope this helps. This should be pretty easy to do, but and once you do it a few times, it's very simple. Okay, so this will help you with understanding how to do it, and also help you with the pre-quiz that will be on Canvas very soon. Okay, all right. I hope that helps people.